Today, we're diving deep into the incredible journey of AI inside Google Workspace. We're talking about a massive shift, moving away from simple, rigid scripts and into a world of truly autonomous AI agents. Agents that feel less like tools and a whole lot more like coworkers.
All right, here's our game plan. First, we'll unpack why this big change was even necessary. Then we'll explore 4 groundbreaking solutions that bubbled up from the developer community. After that, we'll look at 2 brand new frameworks that build on those amazing ideas. And finally, we'll connect all the dots to see where this is all headed.
So, first things first, to really get what's happening, we have to understand the core problem that kicked off all this innovation. What was the challenge everyone was trying to solve?
For the longest time, automation in Google Workspace was all about writing Google Apps script macros, and they were great for simple, predictable jobs. But the game totally changed with this idea of the Agentic enterprise, which really took center stage at Google Cloud Next 24. The dream was to have AI agents that could just figure things out, managing complex tasks across Gmail, Docs, and Sheets without needing to be told every single step.
But as you can imagine, this new power came with a massive new headache. It turns out if you give an AI agent hundreds of different tools and functions to choose from, its brain kind of gets overloaded. It actually gets dumber, its reasoning breaks down, and the cost to run it just skyrockets. Google gave this a name, context bloat, and solving it became the #1 mission for the entire developer community.
And this is where things get really cool. Let's look at how 4 brilliant developers from the community stepped up to the plate. Each of them came up with a totally unique architectural philosophy that honestly laid the groundwork for everything that came next.
This image just lays it all out perfectly. You can literally see the evolution of thought here. We're about to walk through these 4 foundational methods, starting from the more straightforward linear scripts on the left and moving all the way to these complex autonomous networks on the right. First up is Martin Hawksey with his approach called skill-based prototyping. His idea was just genius in its simplicity. He figured, why reinvent the wheel? Let's take all those powerful, old-school command line tools and just wrap them up into neat little skills that a modern AI can actually understand. So here's the key takeaway. What he built was a straightforward pipeline. It connects a local script to Google's command line tools and a remote app script. This approach became the perfect bridge, allowing this new generation of AIs to tap into the power of all that battle-tested legacy code. Next, let's talk about Bruce McPherson. He looked at the scene and honed in on 2 huge issues, latency and security. His solution? He created a local emulator. Basically, a safe digital sandbox where an AI could generate and run code without ever posing a risk to the live system. Now, this is where it gets really clever. This method uses a sophisticated emulation layer called gas fakes to create that super secure sandbox. It also uses some pretty advanced tech, like keyless identity federation, to make secure access a breeze. And it's incredibly flexible. You can run it anywhere, on any cloud, and it can even talk to non-Google systems like Microsoft OneDrive. Okay. Get ready for a radical shift in thinking. To tackle tool space interference head-on, Kanshi Tanieke asked a wild question. What if the AI didn't use tools? What if it built its own tools? He designed a fully autonomous system that literally creates brand new code whenever it needs it. I mean, think about that. It's a total game changer. Instead of giving the AI a giant clunky toolbox that causes all that context bloat, you give it an entire factory. A whole team of 5 subagents works together to write, test, and deploy the exact tool it needs for a specific job right at that moment. The problem of tool overload? Just gone. But Tanaike wasn't done. He came up with another brilliant way to crack the same nut, but from a completely different angle. This time, instead of creating new tools, the main AI would learn how to delegate tasks to another, specialized agent. This is just so smart. It keeps the main agent's mind focused. It's like instead of forcing a CEO to memorize a 160-volume encyclopedia, you just let them call the expert librarian when they have a question. The main agent uses what's called an agent-to-agent protocol to offload its massive skill library, keeping its own reasoning power sharp for the really important stuff. So these 4 community-driven methods were absolute game changers, and they directly inspired 2 new, even more powerful architectures that were designed from the ground up for the security and scale that a modern enterprise demands. And what's so cool about this diagram is how it visualizes that evolution. You can see that the 2 new frameworks, Federated CAR-NCA and SOTCIN,
aren't about replacing the old ideas. No, they're a synthesis. They're all about intelligently combining the strengths of those four pioneering concepts.
So let's break down the first one, federated Kara. The easiest way to think of it is as a super smart traffic cop and a security guard, all rolled into one. Its entire job is to look at a task and send it down the safest, most efficient path. The secret sauce here is its dynamic, zero-trust logic. First, a routing agent asks, hey, does this task involve sensitive data? If the answer is yes, boom, it gets routed to a secure, sandboxed emulator, just like Bruce McPherson's model. But if it's a big, heavy task that isn't sensitive, it gets delegated to a remote subagent, just like in Kanshi Tenaika's model. It always picks the best tool for the job.
And that brings us to the second new framework, SOTCN. This is an incredibly elegant solution that was designed to wipe out tool space interference for good, but without the time delay of having to create new code from scratch. Okay, the way this works is just genius. It keeps this huge library of tools in what you'd call cold storage. When a request comes in, a lightning-fast search instantly finds the top 3 to 5 most relevant tools. Then, an injection agent loads only those few tools into the AI's active memory, just for that one session. It's like having the world's best assistant, one who hands you the exact 3 tools you need instead of just dumping the entire toolbox on your desk.
So let's bring it all home, because what's truly amazing is how these community-driven innovations didn't just stay in the community. They directly predicted and even connected to the official enterprise-grade features that Google is rolling out right now. And this table just brilliantly illustrates that whole journey. You can see a side-by-side comparison of all 6 architectures, from Hoxie's simple command line chaining all the way to the insane security and TSI-proof design of SOTCN. You can see a clear, undeniable progression in complexity, in security, and in raw power. And here's the kicker. This is why this all matters so much. The work these developers did wasn't just some academic exercise. It was a crystal ball. Martin Hoxie's skills idea came before Google announced its official agent skills repository. Bruce McPherson's sandbox is a mirror image of Google's GKE agent sandbox. And Kanshi Tenaika's incredible work with dynamic and communicating agents totally preempted Google's own long-running agents and A-to-A orchestration. The community literally built the future before it was officially announced. This incredible shift from just programming static commands to actually designing autonomous communicating systems, it forces all of us to think differently. The work we've looked at today isn't just about making better automation. It's about defining the very nature of our future digital colleagues. So it really leaves us with one big question. Are we just building better tools, or are we finally, truly, starting to design our first AI coworkers?